Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to a little difficult question on gravitation, question number 7. Question number 7. The question is that the two particles of masses m1 and m2 So the point masses m1 and m2 are at infinite distance initially at rest, and they move under the action of mutual gravitational pull. So gradually they will move towards each other. Solution to this question is, just let me tell you, there are two masses m1 and m2. They are at infinite separations, and they are at rest. So initially the velocity here is 0 and here is 0, and they move towards each other with gravitational force, and at certain instant, when suppose m2 is here and m1 obviously will move towards each other, but I'll keep m1 constant at particular point. When at a particular instant, when the separation is r, this r is the instantaneous separation at any separation r, the relative velocity Vr, you have to prove that it is 2g m1 plus m2, okay, divided by r under root. This is the velocity of separation, velocity of approach at any instant of separation of r. This is what you have to show. So now to solve this question, let us say that when the separation is any separation is r, when the separation is any separation r between these two masses m2 and m1, any arbitrary separation, then the force on this particle will be, what is the acceleration, because we are at relative velocity, so you have to find the acceleration on this particle will be a2, which is negative because this side. Obviously the force is g m1 m2 over r square, so it is g m1 over r square, because the force is g m1 m2 over r square divided by mass of this particle to get the acceleration. That m2 will cancel out. Similarly, the force on this will be g m1 m2 over r square divided by this mass will give me the acceleration. So the acceleration here is toward this side, so it's positive, and it is g m2 over r square. This is the acceleration. Okay, this is the acceleration at which they're approaching. So what is the relative velocity, relative acceleration? So to find the relative acceleration, when I find relative acceleration, say AR, a relative acceleration, it is A1 minus A2. This is relative acceleration of approach. This is A, because this is acceleration will add up, so this is in vector form. So it is by magnitude, it will be, that implies in terms of magnitude, it will be this plus that. So it is g by r square m1 plus m2. This is the relative acceleration. So once I know the relative acceleration, which is I got this value, I know that the acceleration, so the relative velocity, I have to find the relative velocity, say VR, relative velocity of approach, is relative acceleration is this dvr over dt. This I can write that relative acceleration is relative velocity by time, change in relative velocity by time, and this I can also write as d v by dt is dvr over dr and dr over dt. This also I can write because acceleration can also be written this way. This is your v. So instead of vr ar, I'll just write in place of ar I'll write a, and in place of vr I'll write v, because no need to write always this one. So then a is dv over dr, and dr over dt is again v. Okay, dv over dt is v, but then this dr over dt is how is actually negative will come out here. Why negative? Because this dr vector and v vector are in the acceleration, and these two vectors are in opposite directions. So I'll write ADR, okay, is minus v dv, that I can write. And these are all relative velocity, acceleration and relative velocity. Acceleration I've got previously, the relative acceleration, which is this one that I have to put here, g by r square m1 plus m2 dr, and minus v, I can put minus here and write v dv here, no problem with that. And I take the integration both sides of the equation. By taking integration of both sides of the equation, this v dv will be v square by 2 equals to some constant is there, and here also some constant will be there. I'll write that constants. Okay, so this side it is g m1 plus m2, and dr over r square integration will be r raised to the minus 2 plus 1 divided by minus 2 plus 1, that is minus 1 over r, minus minus cancels, 1 over r. So it is only r plus some constant. If I go for the indefinite integration, this is the answer to this. But by going for definite integration, because I know that by putting the conditions, boundary conditions, I'll get the value of c. We know that at v is 0 when r is infinity. So we know that this v equals to 0 when they were at infinite separations. So I write v equals to 0 at r equals to infinity. This condition I can put. Putting these conditions in the above equations, v square by 2 equals to g m1 m2 over r plus c. In this this condition I have put here, this will be 0 equals to g m1 plus m2 divided by infinity plus c. This is also 0, so c becomes 0. So I put c equals to 0 in the above equation. This equation will become v square by 2 equals to g m1 plus m2 divided by r. So this is the relative velocity when r is the separation, or v equals to 2g m1 plus m2 divided by r and under root. But I have to find the value of relative velocity when the separation is r. So when the separation is r, you put r here. So the answer to this question will be 2g m1 plus m2 divided by capital R under root 2. So this is the result I am getting, and this is what you have to prove, that under root 2 gm m1 plus m2 by r. So that is the answer to this question. So this is the answer. Okay, thank you.